Okay, now that we've discussed a little bit about classification methods, a little bit about some techniques that we can use to evaluate classification methods in a supervised learning context, let us look at a classification model, which we have yet to see explicitly yet. So let's ground our problem starting from linear regression, right? So in linear regression, right, you might have seen, let's make a simple problem, that we are interested in predicting somebody's weight based on their height, right? So let's say that this is your height, h, right? And then this is your weight, w, okay? And we were given a bunch of data points. So here are our data points. These are for different patients that come to our clinic or whatever. Very good. And the key here when we did linear regression is what we notice is that the height is a continuous variable, right? It can go, I guess from 0 all the way to 2 meters high or whatever. And the weight similarly is a continuous variable. And that's the key about about linear regression, right? Is that, let's say I'm trying to predict your weight is continuous. Right? And what we did was we said, well, it looks like there's a linear relationship between these two variables. And as my height is going up, so does my weight. And then we said, well, I think one way to approximate this relationship is through a line. So if a line that I could draw as close as possible to all the data points. And that's what a linear regression model did. And this is wonderful. So now let's look at our own problem that we had to do, right? Which is the banking problem. So let's assume for now, for simplicity, we're going to have a single variables as well. So our dependent variable, our label, y, right, is whether you default or not. Question mark. Okay? So that's what we care about in our banking example. Let's assume our x, our inputs, in this case it was height, let's call it B for balance. Okay, let's write it down actually. Balance, which is your credit card balance. And that is also a continuous variable. It could go from 0 to, who knows, infinity maybe. You have a lot of debt on your credit card. Okay, and the goal is I want to predict, are you going to default on a loan that I might give you as a function of your current balance in this credit card that you have with us, for example. Okay, so let's look at what that looks like graphically. So in this case, now what we have is, so I guess we should flip it. Let's say that we did weight and we were predicting height. So our y-axis is height, right? So in this case, right, our y-axis is default, right? And default takes two values, 1 or 0. You either defaulted or you're not, right? So let's have 0 be here, right? And 1 be up here. And this is default, or y, my labels, my dependent variable. And this, the range of default is just 0 to 1. It's discrete. There is no 0.5 or 0.75 or 0.66, right? You either defaulted or not. You don't kind of default. Now on the x-axis here, we have balance, right? Let's say it's balance in thousands of dollars, okay? Hypothetically speaking. So let's create our data set that we will use. So now, the way we set up this classification problem is that I have a set of customers. Just like here, I had a set of patients, right? Patient 1 with a certain weight, patient 2 with a certain weight, etc. So let's correct that real quick here. Let's assume that I was interested in predicting your height in meters based on your weight in kilograms. Okay? So now, instead of having weight 1, weight 2, weight 3, and a corresponding height, what I'm going to have is a balance and a corresponding status. Did you default or not? So let's say I have a few customers, and the balance of customer 1 is equal to, let's say, 1,000. Again, 1 is in thousands. The balance of customer 2 is 4,000. The balance of customer 3 is 0. They have no debt. The balance of customer 4 is, let's say, 8,000, right? And etc. We could go all the way down to balance of customer n, and let's say it's equal to 3,000. And of course, these could have been something like this. Let's make this one more interesting. 3.5. This one 8.1. The balance is a continuous variable, right? It's going from 0 to infinity. And anything in between. So it doesn't have to be discrete. 1, 1.5, 1.99. You could have a credit card bill of, 99 cents all the way to 9,997. You could go any value in the real numbers range. So now, what we're going to do is understand also, did these customers default or not? This is a supervised learning approach. And as we mentioned earlier, in a supervised learning, you are giving the algorithm both your features, in this case just balance, right? That's the only information I have on file currently. And I am going also to have my outcomes, right? My y, which is default. Did you default or not? So y1, let's say, was equal to 0. If you remember, most people didn't default. As we think about this example, let's keep it that way. So let's say y2, you didn't default. y3, you didn't default. But y4 did default. And let's say yn also did default. Okay, so you have a set of data.